Right, so we're starting the next unit of work. So this is Unit 3, which is UK Environmental Challenges. This unit has quite a variety of things in it. So it's basically split into three chunks. So the first bit is all about the UK's weather and climate and the extreme weather we get and what effects that has. The middle section is all about how humans can affect the environment with things like farming and fishing and water transfer schemes. And then the last bit of the unit is all about energy and how our energy consumption and how we get our energy has changed over time and what impacts that has on both people and the environment. So this is the first lesson, what influences the UK's weather. What I'd like you to do is, while we go through this, can you make some notes on this? Because you will need, for revision purposes, notes in your book. It's up to you how you do that. Some of you might want to be writing down as we go. Others of you might want to watch this first and then kind of go back and stop and pause it in places and make notes that way. Learning objectives on there. I'm not going to read it to you. You can read. So first bit is you've got a map here of the UK. And as you can hopefully see, it's split into 4 bits. So we've got the northeast here, which is labelled A, the southwest here, which is labelled B, the southeast here, that's labelled C, and the northwest here, which for some reason is labelled K, but it doesn't matter. In a second, what I'd like you to do is just pause the video and just have a think about what the climate is like in those 4 different parts of the UK. So what I want you to think about is, what is it like in winter? What is it like in summer in terms of the temperature? And then also, what is the rainfall like in those places? So pause video and then we'll come back. Hopefully, this is what you kind of got from your thoughts. So if we start where we are, so up in the northwest, we tend to get, relative to the rest of the UK, we tend to get cool summers. So it doesn't get really, really hot. It's generally unlikely in the northwest to get up to kind of 24, 25, 26 degrees in summer. But it's also not cold either. Okay, so we generally hover in summer kind of between 15 and 20 degrees Celsius, that kind of range. In the winter, we have what we call mild winters. So mild, it is again kind of middling. So it doesn't get really cold in winter. So we don't get many days where the temperature is significantly below 0, but it's also not warm either. And rainfall, as you guys will all know, our rainfall tends to be heavy all year round. We get a lot of rainfall. There is a lot of it in the winter, but you don't really see a massive dip for the rest of the year. There's still rain every month. If we then contrast that to the northeast, so over kind of Newcastle, Durham way, in terms of summers, we're the same. So our summers are both relatively cool summers. We don't get really hot, but it's also not cold. The difference comes in our winters and our rainfall. So if you look at the winters, we have those mild winters. In the northeast, it's actually cold in the winter. Okay, they have, if we compared them side by side, they have much colder temperatures. Okay, it's below freezing much more of the time. And also in terms of rainfall, so the northeast, while it does rain, obviously, the northeast is relatively dry all year round. They have a lower rainfall total than us, quite significantly lower than us. And if you think about things, if you maybe regularly go over to like the metro centre or something like that, quite often in winter, when you go over to the northeast, it does snow. Whereas over here, we don't really get that much snow. Then if we look down in the south of the UK, so southeast, so this is like London, places like that, the summers compared to kind of the rest of the UK are warm. They're warm summers. It's often above 20 degrees in the summer. The winters, similar to kind of Newcastle, they're cold winters. Not as cold as the northeast, but they are generally cold. And then it's very similar in terms of rainfall. It's often dry. There is rain, but it's often dry. If we compare that over to the southwest, again, the summers tie up, so you've got warm summers, and we'll talk about why that is in a minute. But the southwest is much more like us in the winter, so they have mild winters. It's not really cold, but it's not warm. And the southwest, again, like us, has a lot more rainfall. So you can kind of see in terms of, if we look at rainfall, there is a east-west split. So the west tends to have the higher rainfall, the east tends to have the lower rainfall. And in terms of winters, there's an east-west split. So in winter, you tend to get colder winters on the east and warmer winters, or milder winters, I should say. It's not warm. Milder winters on the west. But then summer, it's more of a north-south split. So in the summer, the south is warmer, and in the winter, the north is warmer. Now what we're going to do is look at why that is, because there's 5 factors that influences the UK's climate. So the first one is to do with latitude. So latitude, as hopefully you remember from lower down in the school, is how far you are north or south of the equator. And the UK is in what we call the mid-latitudes. So the mid-latitudes is kind of this band here. So you're not down near the equator, which would be low latitudes, but you're also not up near the poles, which is the high latitudes. Now, latitude affects 2 things. The first thing latitude affects is your temperature. So if I bring this up, so this is obviously the Earth. This line here is the equator. And the colours on here, just tilt it down so we just look at the northern hemisphere. The colours on here show temperatures, and you can see there's clearly 3 different sections. So around the low latitude, so around the equator, it's warm. Up near the poles, high latitudes, it's cold. And then we're in this kind of greeny bit, so this is the mid-latitudes. And we have kind of, again, it's what we call a temperate climate. It's not hot, but it's not cold. Now that's to do with the effect of the sun. So if you imagine the sun sitting out here, you've got rays of the sun, all the sun's energy radiating from the sun. That sunlight is more concentrated on the equator because it's directly above. So they get more heating, whereas the sun rays, as they come out towards the latitudes, because the Earth's curved, the sun rays are spread over a much wider area. They're diffused over a much wider area, so it feels cooler. So the first way latitude affects us is temperature. And that is a kind of whole of a UK thing. One of the common traps you tend to see in exams is people saying the south of the UK is warmer than the north of the UK because it's nearer the equator. I mean, yes, it is, but the difference that makes in terms of temperature is really, really, really tiny. That's not why the south of the UK is warmer in summer than the north of the UK. There's something else that we'll come on to. So kind of watch out for that one. Don't put that down. Okay, it's latitude is a whole country thing for us rather than a regional thing for us. The other way it affects us, and if we go back to the PowerPoint, is in terms of rainfall. And again, this is a whole of the UK thing, not a regional thing. These things on the side are called circulation cells. And you've got air circulating around the globe in the northern hemisphere, these 3 big cells. And what this influences is pressure, because if you have a look where we are in the UK, the air is actually rising. If the air is rising and going up into the atmosphere, the air is going to cool as it gets higher. It's going to cool down. And hopefully you're remembering back to kind of year 7, year 8, as the air rises and cools, it's going to condense. You're going to get clouds, and then you're going to get rainfall. So when you look at the world as a whole, in the mid-latitude areas, you do get higher rainfall levels. Although it's a bit, we'll come on to this kind of later when we do ecosystems. It's a bit more complicated than that. But in general, and certainly for the UK, because you've got this rising air, because we're at the border of the polar cell and the Faroe cell, you've got a lot of rainfall happening for the country as a whole. So that's the first factor. So latitude, this is a whole of the UK thing. So because we are in the mid-latitudes, we tend to be kind of a milder, temperate climate. We're not too hot, we're not too cold. And we do get rainfall because you've got this air rising between these two cells. So that's factor one. Factor two is something called continentality. And continentality is the reason why in the summer, the south is warmer than the north. And also partly why in the winter, it's slightly warmer on the west than it is on the east, although something else comes into that as well. So let's start with summer. Let's just focus on summer for now. So continentality is to do with the difference in heating between land and sea. So land has what we call a smaller heat capacity. So what that means is land tends to heat up and cool down relatively quickly and easily, whereas water tends to heat up and cool down quite slowly. So if you think about where we are, the south of the UK is close to a big bit of land. So Europe's a massive landmass. And because the south of the UK is near this big landmass, in summer, that land heats up very, very quickly. And as the land heats up, it heats up the air above it. And that means that the temperature, if you are near a big bit of land like Europe, is going to be hotter. And that's why in the south of the UK, you get these warmer summers. The north of the UK in summer, however, is surrounded by water, and water is much slower to heat up. So if you're near water, the water has absorbed less heat. It's absorbing that heat quite slowly, and so the air above it isn't as hot, and so that air that's coming in isn't going to be as hot. It's important not to get continentality confused with what we'll talk about a bit later, which is air masses. Okay, so this is continentality is all to do with the fact that land heats up and cools down quicker than water does. And because the south of the UK is near this big bit of land, then in the summer it's going to warm up much quicker and it's going to be hotter because this is all getting hot really quickly. And so that has an effect on the air, and that has an effect on the parts of the UK that are closer. There is a slight effect of continentality in the winter. So because the sea has taken a longer time to warm up, it also takes a longer time to cool down. So in the winter, there is more residual heat. There's more kind of heat trapped in the water, and it's losing that heat more slowly. So what you see in the winter is areas nearer the coast will be slightly warmer. But that's also to do with something else that we'll come on to in a second. So continentality is all to do, and actually I can show you this. So if we go on here, actually it's probably best if we look at somewhere like Canada and the US. So this is temperature again, and this is Canada today. And you can see, I think it's today. Yeah. So you can see that the interior of Canada and the USA is warm. The interior of Canada is colder than the coast. So this green bit all along the coast, you've got Newfoundland and Halifax and all of that there. Over here in British Columbia, it's warmer than the middle parts. The middle parts are much cooler. And if I change this, if we go to August, oh, hang on. Don't want it to predict in the future. There we go. Right, this is August. And August, you can see that in the centre, it's warmer than around the edges. It's only a slight change, but it's enough of a change, and that is because of that continentality. Okay, it's really clear up here. So there you can see it quite nicely. So you've got the hotter bit in here and the cooler bit around the edge. Right, next one then. So, North Atlantic Drift. So the North Atlantic Drift is an ocean current. So it's this one here. So it starts off called the Gulf Stream, and it comes up here as the North Atlantic Drift. Now this is a warm ocean current, so it brings warm water to the west of the UK, because you can see it goes past the west of the UK here. This is one of those things that means that's the reason why in winter, the west of the UK is milder than the east of the UK. Because in winters, you've got this warm water coming up, the air above that water is going to be warmer. And that's obviously going to affect the temperature if you are on the west side of the UK and so you're near this ocean current. It's not a massive, in summer it doesn't create a massive difference, but in winter this west side is warmer because of this warm water which heats the air above it and which warms the western side of the UK. And again, you can see this on here. So we're there. So you can see this warm ocean current which is coming up from the Caribbean, and it's heading towards us. Okay, it's on this particular day, it's kind of petered out in the middle, but you've got this warm water moving up this way. And that keeps this side of the UK slightly warmer in winter than this side of the UK where it's not got that ocean current moving part of it. The ocean currents are there to kind of balance global temperatures. If you didn't have these ocean currents, what you'd end up with is all the warm water or all the hot water, and it'd be very hot water at the equator. And so you get much warmer temperatures at the equator than you do normally. And then you would have the poles much cooler. So the ocean currents just balance things out. But what we're interested in is the fact this North Atlantic Drift, this North Atlantic current comes up here, and just in the winter, I mean, it's there all year round, but in the winter, it just makes the temperatures slightly warmer, slightly milder in the west of the UK than it does on the east. Right, air masses. I'm going to play you a video. I hope this works. If not, I will attach the web link into Firefly for you.
Next time you do this, you could be doing this. How?
If you want to know about the weather, you really need to know about things called air masses. But, what with it being see-through and all that, air is a pretty difficult thing to look at. So first of all, what exactly is an air mass?
Well, an air mass is a name given to a large chunk of air that develops certain characteristics because of where it is on the planet. For example, air that sits over North African deserts is very hot and dry. We call this type of air a tropical continental air mass because it's in the tropics and it sits over the continental land rather than over the sea. With the right weather patterns, this air can come all the way to Britain, As it moves north, it has to cross the Mediterranean Sea, Spain and France, but it will still keep some of the dry and hot characteristics it originally had. So, a tropical continental air mass brings us dry, warm and mostly clear skies. It might bring more than just good weather, as this sort of air mass can give spectacular sunsets and deposits of fine red dust on the ground if it's picked up desert dust from the Sahara. Another easy one to spot is a polar continental air mass, and the name describes exactly what it is. This air mass is called polar because it comes from around the North Pole, and continental because it travels over the land rather than the sea. If this air mass makes it to the UK, it could have come from two different directions, either from the east, moving south from the pole across Siberia and Eastern Europe, or it can come from the northeast, travelling across Scandinavia before it gets to us. This air mass brings some of our coldest weather in the winter. At the end of 2010, the UK was in the grip of a polar continental air mass, and temperatures plummeted to a very chilly -18 degrees Celsius in Wales, the lowest on record for November.
On their journey to us, often across the North Sea, these sorts of air masses can often pick up enough moisture to create really heavy snow showers on the east coast. In Northumberland, on the 30th of November 2010, one of these air masses dumped 40 centimetres of snow. 40 centimetres! But what about weather with a journey over water? Any air mass that travels over the sea will change dramatically on its journey to us.
Polar maritime air arrives from Britain from the northwest. It starts over northern Canada or Greenland, where it's cold and usually pretty dry. However, its long journey over the Atlantic Ocean means the character of the air mass changes dramatically. As the maritime air mass travels across the warm sea, the air is heated and moistened from below. Warming causes the air to rise, and as the air rises, it cools, condensing moisture in the air, forming clouds. When this air mass arrives in the UK, we tend to get a mixture of sunshine, rain, hail, sleet, and even sometimes snow. As we are so familiar with this sort of mixed weather, it's not a surprise to find out that this is one of the most common air masses over the UK. When we hear forecasters predict sunshine and showers, it's probably because polar maritime air is on the way.
We've looked at 3 of the 6 main types of air mass we experience in the UK. When an air mass originates far from us, it'll change on its journey to us. A continental air mass moving over land may alter only a little, whereas a maritime air mass alters massively as it interacts with the sea. Some air masses don't take a direct route to us and will alter as they move over warm and cold seas. The most severe weather we experience comes when cold, dry air from the north clashes with the warm, humid air from the tropical oceans to the south. We don't have enough time to look at every possible air mass in this film, but we've had a look at the basic types and how they change. If you want to learn more about air masses or anything to do with the weather and climate, why not visit the Met Office website?
Okay, so that gave you a bit of an introduction. So air masses are large bodies of air that all have the same temperature and moisture, humidity characteristics. And you can see what they are, what they're called and where they come from. And the key here is to look at the names. So if it says either Arctic or polar, that means it brings cold air. Whereas if it says tropical, that means it brings warm air. So it's kind of a shorthand, a good way of remembering it. If it says Arctic, polar, cold, tropical, hot. For the other part of the name, it talks about maritime or continental. Maritime means it's come over the sea. And if it's come over the sea, then it's going to have evaporated some moisture, so it's going to have moisture in it. Whereas if it says continental, it's come mainly over the land, and so it's going to be much drier air. Now, the air masses are things that affect our weather rather than our climate. So depending on which of these 6 are over the UK at any one time, it will affect the weather. So if you've got Arctic maritime, you are going to get cold air because it's Arctic and it's coming from the North Pole, and you're going to get quite a lot of rainfall because it's maritime, so it's come off the sea. Over here, this one's the one, actually we'll leave that for now because that has 2 bits to it. If we go this way around, so polar maritime. So polar means it's cold. This is the air mass that comes from Greenland and Canada. So cold, polar, maritime, wet. So again, this brings cold, wet weather. Down here, we've got another polar maritime one, returning polar maritime. Again, polar, cold, maritime, wet. So we go down here, you've got the tropical maritime air mass. So this is the air mass that comes from kind of the Caribbean and kind of the Atlantic Ocean. So it's maritime, it's coming over the ocean, it's going to bring a lot of rainfall with it because it's moist air, but it's also tropical, so it's going to be warmer. And then down here we've got tropical continental. Now this is from Africa, so it's going to be warm. And because it's mainly come from the land, it's going to be dry air. So there's not going to be much rain associated with this air mass. Obviously, I mean, it crosses the English Channel, it crosses the Mediterranean, but overall it's dry air. Now, this is one I said it's slightly tricky. So this one says polar continental. The problem with polar continental, it's not a problem, but the thing you need to remember about polar continental is it varies between summer and winter. So in winter, polar continental means what it says on the tin. It's cold and it's dry. However, in summer, even though it says polar, in summer it's actually bringing some warm air. Okay, still dry because it's still coming from the continent, but it's bringing warm air. So the polar continental air mass comes from Central Eastern Europe, comes from Russia, and those places in the summer are quite warm because they're a big bit of land. So they're warm. So in the summer it brings warm air, but in the winter it brings cold air. Okay, so just be careful. Polar continental can trip some people up. So there are air masses. Sometimes you'll have one air mass dominating the UK. Sometimes you'll have a few air masses over different parts of the UK. You often see, if you watch the weather, they'll often say, oh, we're now getting a spell of cold air coming down from the Arctic. And they're talking about Arctic maritime conditions. Now, related to air masses is something called the prevailing wind. So the prevailing wind, as hopefully you remember from when we looked at coasts, the prevailing wind is the most common wind direction for the UK. So we did this, the prevailing wind direction for the UK is coming from the southwest. This links to air masses. So if we look back at the air masses, from the southwest is our tropical maritime air mass. Now, if you've got the main wind direction, so the main kind of bulk of air coming from the southwest, in the UK, you're going to have a lot of tropical maritime air. So these two things link together. These things are wind roses. I've put it on here just so that you can see it and you know what it's called. So wind roses are a type of graph. They show two things. So the size of the bar kind of out this way at the compass points show where the main wind direction is coming from. So in both of these cases, you can see the biggest one, or the biggest bars, are coming out towards the southwest because that's our main wind direction. And then down here, our bars, around here, our bars are smaller. Now, obviously, you get changes in wind direction. So just because the prevailing wind direction is from the southwest, that doesn't always mean our wind comes from the southwest. So you can see here, there was a pretty big easterly wind when that one was taken. The size of the bars here is talking about the wind speed. Okay, so these are wind roses. Putting this all together, you've now got, or you should now, understand what the climate is like in the 4 different parts of the UK, and also why that is. So you're talking about those 5 factors. So what you now need to do. So I am going to attach onto the Firefly task a copy of the textbook page, which you can use in conjunction with this video. And you will need to make some notes on those 5 factors and how they affect the UK's weather and climate. I'm also going to put that blank map or one very similar to it on Firefly as well. And what I want you to do is annotate it to produce a diagram similar to this, to say what the different climate is in the 4 different parts and why that is. And if I can find it, I will attach as well an example of a really good one of that, so you can look at that. And then I'm going to attach a A4 sheet of questions that I want you to complete, and then can you submit that on Firefly, and I will mark that and get it back to you.